All right, let's finish up chapter 5. Isosceles triangle theorem, triangle inequality theorem, hinge theorem. Sounds like we got a lot of theorems to learn. Okay. The triangle inequality theorem states that the sum, means adding up, of any two sides of a triangle must be greater than the measure of the third side. Well, that makes sense. We'll get to some practice problem samples at the bottom. The isosceles triangle theorem states that if two sides of a triangle are congruent, that's what we know about isosceles triangles, then the angles opposite those sides are congruent. The base angles. Now the converse, remember, is to reverse it, flip it around. The converse of the isosceles triangle theorem is often called the base angles theorem. Now remember, converse is backwards. So if two angles of a triangle are congruent, then the sides opposite those are congruent. Okay, so they're basically telling you the same thing. One is the converse of the other. So let's look here. Which theorem is represented here? If two sides are congruent, then that's what the arrow means. The angles opposite them are congruent. That is the isosceles triangle theorem. In this picture, two angles are congruent, then the sides opposite those angles are congruent. So that's the converse of this. Converse of, and I'm going to abbreviate, isosceles triangle theorem. And again, you may hear this referred to as the base angles theorem. All right, the hinge theorem is the last one covered in this lesson. Hinge works like a hinge, like a stapler when you open it, or a door when you open and close it. Okay, the hinge theorem states that if two sides of a triangle are congruent, sounds familiar, isosceles triangle, and they're congruent to two sides of another triangle, then the included angle, that's a big fancy way to say between, of the first is larger than the included angle of the second, then the third side of the first triangle is longer than the third side of the second. Whew. Well, here's a picture to support that. Albert and Andy Alligator are twins. They have the same upper and lower jaw measures. I know you can't see that in my original picture. They were red and blue, which is not helpful. Okay, however, Andy has his mouth open wider. See, you can see angle D right here is larger than angle A. This means that if they were about to attack you, the stick that you would need to prop open Andy's mouth would need to be longer than the one for Albert's mouth, right? So this is longer, and this one is shorter. And it all stems back to the angle opening, okay? So let's fill that in. That means the stick you'd need to prop open somebody's mouth is longer. Well, we decided Andy's mouth is wider. It needs the longer stick than the one used for Albert. All right, let's do a little practice. All of this is now going to be in picture form, which some of you need You learn very well. Can these links form a triangle? Whoa, what happened to my focus? There we go. Well, at the top it says the sum of any two sides of a triangle must be greater than the third. 4 plus 10, that's 14. That's bigger than 3. But I got to check them all. 10 plus 3, that's 13. That's bigger than 4. However, 4 plus 3 is 7. 7 is less than 10. So no, I cannot make a triangle out of those side lengths. So you're probably pretty clever. And I bet you've already figured out that you really only need to check the small sides. Obviously, if you add the large side with something, it will be bigger than another small side. So small sides here, that is 17. It is larger than 16. So yes, those side lengths will form a triangle. 5 and 5. Well, that's 10. And 10 is equal to 10. And I believe it says in the theorem that it must be greater. Equal is not good enough. It will not form a triangle. All right, now we have the two small ones over here. Don't go by just the first two that you see. You have to choose the smaller two. So 5 is smaller than 7. So 2 adding up to be bigger. Yes, that is going to work. Now, based on this, let's do a little example before we do these. What could be possible numbers over here? Well, let's check it out. Let's say I put a 1. Can that be a 1? Let's see. 3 plus 1 is 4. 4 is not bigger than 8. So no, it can't be a 1. Can it be a 2? That's 5. 5 is not bigger than 8. Could it be a 4? Nope. So we've used 1, 2, 3, 4. Could it be a 5? 5 plus 3 is actually 8. So 6 is the first number that would work on this side. 6 plus 3 would give me a 9, which is bigger. Well, how far could I go up? Could I use a 7? Yep. 8? Yep. Can I just go forever? Well, I don't know. What about a 20? Well, 20 plus 3 is bigger than 8, but let's check the smaller two sides. 8 plus 3 is 11. 11 is not bigger. I can't go to 20. So how far can I go? Well, can I use a 10? Is 8 plus 3 bigger than 10? Yeah, so 10 works. So 7, 8, 9, 10. Does 11 work? 8 plus 3 is 11. No, it doesn't work. So the only choices I could get would be anything bigger than a 5 and anything smaller than 11. So X has to be between 5 and 11. Remember what this says from Algebra 1? X is bigger than 5 and X is smaller than 11. Now, it doesn't have the equal to. That's why I don't use 6 and 10. So that's the range of possibilities. Well, I don't know about you, but I don't have all day to sit there and guess and check. Let's look at this 8 and 3. Can I get a 5 out of 8 and 3? Oh, absolutely. 8 minus 3 is 5. So there's the lower bound. You're right. 8 plus 3 is 11. There's my upper bound. Well, that is a lot faster than guess and check. All right, let's look over here. So I'm going to take the 15. I'll have 15 minus 12, and I'll have 15 plus 12. Those are going to give me my upper and lower bounds. So 15 minus 12, 3. 15 plus 12, 27. All right, I want you to do B and C. We'll come back and check them during class. All right, let's move down and check these. Now, did you notice the markings right here? Oh, two congruent sides. We know something about that right here. If two sides are congruent, then the angles opposite those sides are congruent. So that means 52 is equal to y. Perfect. Oh, I didn't have to find that. Oh, yes, I did. Because now if I know this is 52, I can do 180 in a triangle to find x. 14x plus 6 plus 52 plus 52. Algebra 1 coming back to you. I'm going to take 180 and subtract all of that off. That's 70. And now we divide. 70 divided by 14, x is 5. It's not bad, is it? All right, let's look here. Did you notice all three sides are the same? The three congruent sides means three congruent angles as well. So I know all of these angles are also 60. Equilateral triangle is also an isosceles triangle. So let's start with x. I know that's equal to 14. Sides are congruent. Distribute, subtract, and divide. So that is 4x equals 12. X is 3. Now it's time to look for y. And it's a little difficult to see. This says 6x plus 7y degrees. That is a tiny little degree symbol. So it's talking about an angle. I will not use this or the 14. However, I already know x. And every time you've got a letter in the same diagrams, they have to have the same value. So that means anywhere an x would be here, it has to be 3. So now I'm going to have 6 times 3 plus 7y, but it's equal to 60 degrees. So 7y equals 42. I removed the 18, and then we divide. Y equals 6. I am going to let you do 5. It is the converse of the isosceles triangle theorem because you've got congruent base angles. So that tells you which two sides are congruent. All right, you can solve from x. Turn it over. A circle. All right, I do know that from the center to the side is a radius, and center to the side is a radius. And of course, the radius would have to be the same measure. That means angle B is congruent to angle A. 180 in a triangle, and you are set. So 130 plus, I'm going to let angle B and A be called x's. I don't know what they are, but I know they're the same. So 130 plus 2x. I can subtract the 130 and then divide by 2. It looks like both angles will be 25 degrees. Look at 7. Did you notice? Congruent, congruent. Okay. Right here, if the sides are congruent, then the angles opposite those sides are also congruent. So that means x plus 10 also goes here. Now we can go 180 in a triangle. So that is 1, 2, 3, 4, 5x, 10, 20 equals 180. And then divide, I believe x is 32. And here we've got some porches on our triangle, some exterior angles. All right, I do see that we have congruent angles, which means these two are the same. Luckily, we know that linear pairs make 180. So 180 equals x plus 138. I believe that's 42. So both of these corner base angles are 42. What is the measure of angle x? Well, now we can complete it. So we'll have y plus 84 is 180. And all I need to do is subtract, and I believe we have 96. Okay, let's talk about the hinge theorem for a little bit. List the sides in order from greatest to least. That means I need to know all the angles. So 48 and 21, take it away from 180, leaves me 111. Okay, remember here, Andy's mouth was open wider, so it's across from the longer side, across. I'm looking for the biggest angle. It has to be across from the biggest side. So angle C is the biggest. Who would be next biggest? Medium? Well, medium angle across from the medium side. So C is bigger than B, which leaves A to be the smaller side. All right, now this one says angles and least to greatest. Okay, angles are across from sides, that's no big deal, but I need to choose the smaller side. That looks like 2.1, and that is across from angle Y. So angle Y is smaller than, looks like 3.6 would be next, and that's across from X, which is smallest. Oops, I was about to write 4.7, and I don't want the side, I want the letter W. Now, if you have a composite figure, I'm wanting the sides from greatest to least. It says, give you a hint, start here, because that's where the bigger numbers will be. Well, again, 79 and 64 from 180 leaves me 37. You've got to have all the numbers before you can start. In the small triangle, 67 and 27, remove that from 180, we get 86. Now we are ready to roll. Okay, in the big triangle, 79 is the largest. So that means E is the biggest, followed by D, followed by Z, which is across from C. So that takes care of the large triangle. Notice how side Z, C, excuse me, now jumps us into the next triangle. It's across from X, which was the largest side here. So medium would be across from the 67, so that would be A, which leads B to be the smallest out of all of it. Look at 12. All right, we know the perimeter, so that means I'm going to have to solve for X, plug it in before I can do this. So 12, 13, 14, that is 19x. Now add up all the non-x's. Well, remember you're subtracting that 19. And we know the perimeter is 119. So let's subtract the 43 and divide. So x is a 4. Well, let's plug it in. Well, 5 times 4 is 20 minus 19. This side is 1. I know it doesn't look it, but we don't go by our eyes. 2 times 4 is 8. 8 plus 28, 36. 12 times 4 plus 34. So what is that? 48 plus 34. It's a big number. I get 82. All right. So now, largest, well, that's across from the 82. So, right, that means angle T has to be the biggest angle here. Medium would be across from the 36, which leaves angle A to be the smallest angle here because it's across from the 1. All right, let's look here. It's still more Hinge theorem. Now I'm going to be comparing these two. Congruent, congruent. So these are like the twin alligators. The 63 is across from this side, the 82 from that side. Well, that means 63 is the smaller, across from the smaller side, and the 82 is across from the longer side. So AC is less than DF. Seven and 6, you can see the other sides are congruent. That would mean this one's big, this one's small. A B C is bigger than the E F. All right, last problem on the notes before we get to our practice problem. Which plane is closest to the airport? And I know that's difficult to see, but there is a plane here and a plane here. Here is the airport. 181, they're both the same distance from Simpson City. So I'm going to look at the angles. 48 degrees is across from plane 2. 113 is across from plane 1's path. Well, 113 is bigger, so this must be the longer side. 48 is smaller. This must be the shorter side. So who is closer to the airport? It would need to be plane 2. All right, it is time to get to those practice problems.